okay? But I made a new question that I like better because this question doesn't have multiplicity, and I want us to practice one with multiplicity. Is that all right? Okay. So we're going to do not this one. We're going to do this one.
Making a YouTube video?
Yep. I sure am making a YouTube video, and I will do no editing. Follow my channel. I have no idea how to get there. I actually don't even know if I have a channel. If I post videos on YouTube, do I have a channel? I do? Oh. Whatever. But if you find my channel, I actually have some pretty funny karaoke videos on there I sent to my students during the COVID shutdown. You have to dig through the depths, but they're pretty good. I sing a really good Shallow by Lady Gaga, and I also do Bradley Cooper's part. It's pretty good. Okay, just wanted to make sure you guys were aware. Okay, what do I do first? GCF. What is my GCF? Heck no, it's not. Negative X. The first one's negative. I gotta take the negative out. So my GCF is negative X.
Oh, bet.
Hey, how many factors is this one gonna have?
4.
Try again. 5. It's an X to the 5th. But I already know one of them is negative X, right? So X equals 0, good, is my first solution that I know. Man, you guys are nailing it. What? He said. Why? What makes negative X equal 0?
Plus X.
Try to 0? Okay, then I have X equals 0. Oh, okay, that worked. Hey, what are my possible rational roots to try now?
Oh my gosh, I found one.
What is it?
Wait, I think it's x minus 1. I don't know if it's for sure. I gotta finish. Hold on.
Well, you guys don't have to wait. You can try it too. Our possible rational roots to try are plus or minus 1 and plus or minus 2.
I don't think it works. No, it doesn't work. That's an L.
It should have worked. Yeah. Yeah. Are you guys trying your possible rational roots?
It's the constant.
That's what you guys should be trying, is your possible rational roots.
If we want to have the last one is 1, first one is 2.
What makes that 0?
Yeah, this one doesn't work.
Try
Well,
negative.
what number can I plug in for 0 to make that equal 0?
Yeah, I found one.
Okay. This is not.
Wait, there's only 4. Wait.
Yeah.
I was trying, I don't know.
Dude, if there's only 4 possible solutions, shouldn't all 4 solutions work?
Yeah.
Oh, there's true.
Negative 1. Negative 1. It's negative 1.
Yeah, it's the
Since
constant.
it needs all 4, it's going to be all 4 work.
X equals negative 1 or x minus 1?
So it's X. Is it equal to 2 over 1? X plus 1.
Oh, I tried
X
that
plus 1 is
negative. Alright, sick, bro. 1.
Hey, which one should we try
X
first?
plus 1. Let's go.
Negative 1?
Yeah, and 1.
And 2 works in 1? Okay, keep that in mind. Let's do negative 1 first. If I'm going to try negative 1 first, then what is the factor that goes with it?
X plus 1.
Nailed it. The remainder theorem. No, just in your final answer in the end. Once you pull the factor out, you can pretend it's not there.
Also, with this one, the negative X, that's it. So negative X is equal to X.
Now, how do you do that on your calculator again? Right, that's where you can do it.
Yeah.
Oh, this one?
Okay, we'll try x equals 1 next. I love that you guys are finding the next ones to try because that means you're ahead of where I'm at on the board, which as a teacher, my little teacher heart is like, yes. Also, it was in this class that one of you guys, I don't remember who, the other day on a warm-up, called the extra box when I completed the square the remainder instead of the extra box, and I told all my teacher friends. I was like, my little teacher heart is like, oh, the connections they're making. Oh, I love it. Oh, just so proud. Just so proud.
You know, this is a long freaking equation.
Heck yeah, it is. Why do you think we spent 6 days doing it? Okay, we said that 1 would be next, right? So, do I go back to the x to the 4th? Oh, I keep forgetting. You guys remind me every class period. I really appreciate that. Why am I having a brain freeze? I don't do -1 times -1x. No, -1x. There we go. Okay.
X plus 1 multiple C 3. What are we calling it?
Wait a minute. No, that's right. Is that right? I'm getting confused with my negatives and my x's. Oh yeah, it worked. Yes! So then, now I have my quadratic, so I'm going to go x minus, wait for it, what adds to -1, but multiplies to -2. Oh. Does it work?
It works. Or I'm gonna
And then I rewrite.
It works. Well, what are the numbers?
-2 and 1.
Nailed it.
Oh,
Nailing it. So x minus 2. Remember, the puzzle gives factors, not roots. So I'm not changing the sign for the factors, right? Wait a minute.
wait.
I can write that better, can't I?
Yeah.
Because one of them has a multiplicity. Yes, so there we go.
I already forgot. X3 times -.
Which means that here, I'd say multiplicity 2 and then 1 and 2. Okay, so let's stop there. That's combining everything we've done in 2.4, 2.5, and today. So what questions do you have on that? You guys, this process is long.
Is this all of it though? Like, is there any sorting?
Well, I mean, I'm gonna finish this problem off.
Well, no, I mean just like we're not adding anything new onto this, right?
Oh my gosh. Do you remember how I told you today was the last day of the unit?
Okay, I'm just checking.
I
feel
know.
like teachers always do that. It's like, oh, also there's just this one other thing, and it's like,
Yeah.
what?
Well, we just like to keep you on your toes. Yeah.
Well, I don't like being on my toes.
It repeats twice.
Yes. Yep. Yeah. I erased and I fixed it on this one. The -1 is the one that has the multiplicity, right? Okay. Questions up to here? Yes, Maddie.
I'm kind of confused, but worry about -2 plus 1.
Well, once I had my quadratic equation. Oh, that's an eraser.
What?
Once I just started erasing it. Once I had my quadratic equation, then think back to secondary 2 last year, and I'm trying to factor that, right? And when you factor, you look for two numbers that add to the middle number, -1, the B, but multiply to the last number, the -2. Okay? Yes?
So why did you get a new puzzle?
Good, because I had already divided out this factor at the beginning, right? But then when I factored my quadratic, I realized that that factor was in there again. Right? Good. What else? Okay. Careful. This one, it might mess some of you guys up. Careful. What's the y well, first of all, let me ask you this. Which of the different variations of this polynomial do I look for the y-intercept in? Which of the different variations of my polynomial do I look for the y-intercept in? The original. What's the number without a letter in the original? There isn't one, it's 0. So my y-intercept is 0, 0.
Yep.
Okay?
Oh, scrap it. Oh.
So 0, 0. And then my solutions are also intercepts. I don't need to write this 0, 0 again, right? Because the fact that it's a solution is also covered by the y-intercept here. Does that make sense? Okay? So then negative 1, 0, 1, 0, and 2, 0. Okay? Now I want my end behavior.
You scroll up.
Yeah.
Odd.
What is my end behavior category first? Negative, odd. Because the negative 1 is the leading coefficient and 5 is odd. So that means its end behavior is x goes to infinity, y goes to something. Nailed it. Now, you guys, the end behaviors, the understanding part of it is what category it fits in. Once you figure out what category it fits in, the end behaviors are just a matter of memorization. So if you can figure out the negative odd, but then you can't figure out the end behavior, then you just have to get it memorized. That's what it is. But if you still don't understand why it's called negative odd, let me or Mrs. Hooper help you one-on-one. Okay? Does that make sense? Okay, so on your graph you glued down for me, let's plot my intercepts. And then I know my end behavior looks like this, right? Now get this far, then put your pencil down and watch Miss Summers on the board. Okay, get this far, then put your pencil down and watch Miss Summers on the board for a second. Okay? I'm going to try and connect these, and I want to make a mistake that you guys are going to catch for me so that you don't make it on your papers. Are you ready? I'm going to try and connect these dots. Well, okay. Wait a minute.
Well, you can't do that many curves.
It should bounce on the last one.
Oh, that bounce. That bounce is what makes this possible.
And it makes it the M2.
Yes. So really, which one is the bounce supposed to happen at? This is why isn't it the negative one? I can't remember.
Yeah.
Negative one. But this is why that multiplicity thing is so important, because when I try and figure out how to connect them, I have to bounce and then go through. Then I can play my connect the dots.
Oh, yeah.
I feel like you guys can handle one start to finish. Do you guys feel like you can handle one start to finish? Well, we'll walk around, okay? But this one is, I don't like it either. Look how giant those numbers are. No, thank you.
Yeah, really not.
Yeah.
I'm gonna give you a different one again. I picked out ones I like better. What the heck? Do you want to practice one together that needs the quadratic formula in the last step, or do you want?
It's on the homework.
It's on the homework. Okay. Okay. This one's gonna have all the things. It's gonna have multiplicity. It's gonna have end behavior. It's gonna have all the things. Quadratic formula. You guys are nailing it.
By ourselves.
Yep, you're gonna work on it alone. We'll walk around and help. Eraser.
Rage.
Rage.
Is it X5?
Let me finish writing
What
it.
if you can't like factor out anything and it's like an x to the 5th power?
I did not give you any of those.
I know. I'm just saying, like, what do you do? Because the quadratic formula is only good for like.
For quadratics,
Yeah.
there's other methods that you can do, but not ones we'll do this year.
Is there a cubic formula?
There is, but it is like half a page long. It's not an easy formula. Actually, I'm sorry. Well, the one I was about to write had a y-intercept of 42. Do you want to deal with that? No, you don't. Okay? Thank you very much. Okay, don't forget, I want, as you try it on your own and Hooper and I walk around and help, I want factored form, I want a list of intercepts, y and x, and I want end behavior, and then a graph. GCF is X this time. Good. Okay, you guys are going to try it on your own.